Okay, so we're recording. Hello YouTube. Second day of Advent of Code. Yesterday we did the first 3 exercises. Today is actually day 6, but I'm falling behind. Well, I started late because it was busy the first few days. Yesterday we did the first 3 exercises, mostly without many problems. Not everything worked out first try, but yeah. Didn't have any big issue. We rediscovered split, we rediscovered tokenize, very good functions, and I bet you the tokenize will get me through the parsing stage of every exercise until the end, or actually I don't know, but I think it's gonna prove good enough. And I think this is an interesting point, especially for people who are used to immediately recur to regular expressions, which are not bad. I like regular expressions. I don't have an issue with them. I enjoy them, learning about them, and I can't claim to always be able to come up with the correct regular expression right away, but I don't find that a particularly problematic process. But even then, I am strongly convinced that tokenize is good enough very easily. You just need to add a little bit of extra logic to it occasionally, which I'll show when the time comes in the exercises, and it can get you very far in Advent of Code. Of course, Advent of Code, it's like a limited parsing task, I guess, because you only care about parsing, well-formed data. In reality, parsing is equally about good data as it is about bad data, but we don't care about that in Advent of Code. So let's get started, and let's see where we can get today. As a reminder, Zig website to download Zig. Language reference, really good to learn in case you have questions about Zig syntax. And standard library documentation for knowing what's in the standard library. Our best friends that I mentioned earlier, tokenize, is inside mem, std mem tokenize, and split. You know what? I'll fetch split from here. Okay, typing would have been faster. Well, split returns an iterator that iterates over the slices of a buffer that are separated by bytes in the limiter. Yesterday we had a case where split was better than tokenize, but most of the time actually you want to use tokenize. At least that was the case in the previous Advent of Code. So let's get started. As usual, I'm developing inside my Linux machine, my Linux virtual machine, and I'm using Helix as my editor. I already prepared the day4 directory. So let's go to the Advent of Code website and let's click on exercise number 4. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned to the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair, your puzzle input. For example, consider the following list of section assignment pairs: 2, 4, 6, 8, 2, 3, 4, 5, 5, 7, 7, 9. 2, 8, 3, 7. This looks like it's overlapping a lot. Let's see. First 2 pairs. Within the first pair of elves, the first elf has assigned sections 2 to 4, so it's including also the upper bound. So there is no overlap, but these guys are overlapping on the 7, right? The elves in the third pair were assigned 3 sections. 5, 6, and 7, the other got 7 plus 8 plus 9. Okay, this example list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pairs of section assignments look like this. Yes. Okay. Some of the pairs have noticed that one of their assignments fully contains the other, like this guy here, this guy here, like the... Man, why is selection so bad on this website? Like these 2 guys. For example, 2.8 fully contains 3.7, and 6.6 is fully contained by 4.6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning, so these seem to be the most in need of reconsideration. In this example, there are two such pairs. In how many assignment pairs does one range fully contain the other in your puzzle input? Okay, let's copy everything. Pasting it inside my data.txt. Wait, am I in the data.txt? No, I'm in the scratch. Undo. Let's go in data.txt, paste. We have 1,000 pairs, okay? Main.zig. Import standard library. We embed data. Again, embedding is a shortcut. It has, in real software engineering, you should use this tool, you know, with a little bit more caution, but in this case, good enough. And saves us from a bunch of, I don't know, boilerplate stuff that is just boring to do. No, pub function main. Also, give us the possibility of throwing errors. Okay, so first of all, we want to iterate again our input line by line. So var line it. Did I do a line it? I think it's not a bad idea to do line it and then split on the comma afterwards. So line iterator, std mem tokenize bytes, data is our starting point, and we want to tokenize on new lines. So this gives us lines. So while we have lines, what do we do with each line? We need to split on the comma, right? Well, yes, we need to split on commas and dashes, right? And if you think about this in a structured way, you probably want to first split on the comma and then obtain two pairs. And then you can split on the dash. But we can cut corners. We don't have to think about things in a structured way. We can decompose this a little bit more and we can cheat. So here's how it's gonna work. I'm gonna make another iterator. I'm gonna call this one just IT. And here's how it's gonna work. std.mem.tokenize u8 data, and in this case, I think the limiter bytes, you can read here in the description, right? Returns an iterator that iterates over the slices of buffer that are not any of the bytes in the limiter bytes. No, in this case, it's a string, not just a single character, because tokenize as it's implemented in the standard library, as you can see, accepts a list, and it does, and basically matches over any of them. So if you only have one, you want a string that contains a new line, not just a new line character. So for the second part, here's what we do. We split on dashes and commas. And when we split on dashes and commas, here's what happens. Then we get this const. I guess we'll call them n1 and 2 and 3 and 4, or maybe xy. Let's do x1, x2, y1, y2. No, x1, x2, y1, y2. There we go. So in this case, we're doing the split all together. No need to do it like multi-stage. Okay, so we have all these things, but also we want to make numbers out of them. Should have done this before copy pasting. Oh well. Try std fmt dot parse int usize this thing base 10 We saw the signature of USI of parseInt yesterday, so you know what? Yeah, I'm redoing this thing. Okay. So we have our 4 numbers. Okay, the question is, we need to find out when one range is strictly contained inside the other. So here's how it works, I guess. If x1 is greater than x2, actually, you know what? No curly braces. So the question is subset, right? And then we need to count those. Okay, so we have a counter. And then we say it's subset if x1 is greater than x2. What am I doing? X1 is greater than, sorry, y1 and x2 is lower than y2. That's the case when the first one is a subset of the second. And I guess we want a or. So you know what? I'm gonna add some parentheses to make this nicer. Or now we want the inverse. So we want x1. Wait, we want y y1 to be lower than. No. Wait, okay. In the first case, x was the top one. No, the first one was contained in the second one. Now we want the inverse. So we want x1 to be lower than y1 and x2 to be bigger than y2. Something like this. I'm missing a parenthesis. Okay, Z1 sit on a single line. Is this, I hope that I don't have to specify U size inside the expression. And then we do counter plus equals is subset. Probably didn't have to make this an expression. Could have just made this a much more normal statement and just done the increment in one of the 2 cases, but whatever. That seems like it. I don't know. Let's see. And use capture. Oh yeah. Oh, woof. Thank you for that thing. Yes, because I need the second iterator to be based on to be tokenizing my line, not the entire data. Although to be fair, well, never mind. Let's just continue. Right. Might also want to print the outcome. That's 204. Did I get my conditions right first try or not? We'll see. 204. Oh, that's not the right answer. I messed up my conditions. Okay, let's double check then. Let's double check them. Okay, you know what? Let's do a normal if, since we are trying to double check this because it's messed up. Let's add curly braces. Good old-fashioned curly braces, right? And we just do the increment in there if necessary. Otherwise, we don't do anything. Okay, let's double check this. We want x1. Oh, you know what I'm missing? equality, because we have our extremes are both included, so we always want equality to count. Oops, yeah, this is not an operator. This is not an operator either. Oh, we don't have a subset anymore. In this case, we just want to increment with 1. Okay, 500. Let's see if this is correct. That's the right answer. Forgot about the extreme case. Continue to part 2. Part 2. It seems like there's still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. We want any overlap. In the above example, the first 2 pairs don't overlap, while the remaining 4 do overlap. Okay, so we want the count of how many overlap. Okay, so how do we know if they overlap at all? I think it's I mean, by itself it's not a complicated problem. I was wondering if there's like a very simple transformation that you can make to the condition here to like make it work right away. I don't know, you flip around ends and ors. So let's see, they overlap. If x1 is greater than y1, to overlap, x needs to be lower than y2. x1 needs to be lower than y2. That's all it has to do. I don't care about x2 at all, because I know that x2 is going to be bigger than x1, and I only care, I only need 1 point to test for this thing, and I guess in this case it's the same. If x1 is lower than y1, then all we want to make sure is that x2 is bigger than y1. That's it? Maybe? 815. That's the right answer. Okay, that was easy. Let's go to the next day, day number 5. And also, before we read, let's prepare our stuff. No, touch, data.txt, main.save. And let's open data.txt. Okay, the expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. Is this the Tower of Hanoi stuff? Oh man, is this search with backtracking? The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crashed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator doing these delicate procedures, so... Oh, but they forgot to ask her which crate will end up where. And they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, your puzzle input. So for example, oh, that's the starting state, and then you do move one crate from column number 2 to column number 1. Okay, so we are dangerously approaching virtual machine territory here. Oh, it's much easier. Okay. So I think I guessed right. Let's see. contains 2 crates. They are crate finally stack 3 contains. Okay, then the procedure. So yeah, this moves the here. Then move 3 from 1 to 3. Then moves everything over P. So it's DNZP. What is going on here? Oh my god, the thing moves only one at a time, so it can't pick up all the crates all at once. It has to pick them up one by one. Okay. Hi there, Toyfell. Hello, hello. Okay. It's inverse order in part 1. Yeah, it picks them up one by one. Okay, fine. In each step of the procedure, a quantity of crates is moved from one stack to the different stack, blah blah blah. Yeah, one at a time. Look, it's highlighted. Then again, the crates are moved one at a time, so you need to keep track of ordering. The elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. So you should combine these together to give the elves the message CMZ. After the arrangement procedure completes, what crate ends up on top of each stack? Oh god, are we parsing? Holy shit, this is gonna be fun parsing. Okay. Oh, you did the manual declaration stuff? Okay, we'll see how it goes. I think I have a plan. We'll see. Okay, so we pass everything, and first we need to deal with this, right? We need to deal with the first 10 lines, and then we need to deal with the rest. As part of the stacks are padded with white space in the input. Yeah. Yep, fixed size helps a lot. Okay. Void. Man, why can't I type? Okay, void. So we need to parse the first few lines, right? So let's parse the first 9 lines to get the state of our 9 stacks. I guess it's easier maybe to do that column-wise. So let's do our 9 columns. That's how I want to structure this stuff. Also, our 9 columns need to be... It could be arrays. But if we make them arrays, then we need to, you know, keep track of how big they are. We need to find the biggest size. We don't know how big each array could be, right? Because it depends on the instructions and how they move crates. We could, I guess, count the number of crates, and we would know the worst case, which means all the crates on a single column. But I think I'm gonna take it easy and just use array lists. So I'm gonna make 9 array lists. And then I'm making an array of those so that I can index into them easily. So let's make our stuff. Var stacks is an array. Hello, Donald boy. It's an array of 9 array lists. Nine array lists of what? They have letters, right, on them? Yeah, each stack has a letter, so I guess it's fine. Welcome man, how are you? I think you were gone, right? I didn't stream for a while. I was busy with other stuff, yes, but now I'm doing the advent of code. Array lists are the way. Array lists are the way to go. Don't make it harder on yourself. Yeah. I think so as well. Okay, so these are 9 stacks. Now, we can do this. So this is our type. We set it to undefined. We don't really initialize it because, like in this expression, because in any case we need to initialize them by looping on our data. So now var, let's say, you know what? Also, here's another trick. Let's do the initialization inside a block so that we don't pollute the namespace too much. So var C is gonna stand for column. USize is 0. Well, you know what? Should we? Right, we have to be 0 indexed. While those IDs go from 1 to 9, that's annoying because it means that we either leave the 0th index. You know what? Let's put 10 items in here, and we leave the 0th initialized, uninitialized, just so that we don't have to adjust offsets. That's the entire reason for it. We waste some memory, but we gain in simplicity. That's my executive decision. So C stands for column. So let's start by doing column 1 then. So for column 1, first of all, we initialize our stack. Stacks column C. Also, wait, it's a while loop. While C is lower than 10, or you know what, or equal to 9, and then C plus equals 1. That's our increment step. Then we have our loop. In this loop, we do stack C .init, and we need an allocator. GPA.allocator, and I need to make GPA a thing, so let's make GPA a thing. There we go. Can I have some indentation, please? What did I do wrong? What do you not like? Oh, you need a space in here. There we go. Okay, so we initialize the array list, and then we need to put in there our numbers. So now we need to iterate for each row. So var row usize. The space thing is really weird. It's to avoid ambiguous stuff. Okay, so we start for the rows. I think we want to start the rows at 0 this time. We don't need to offset them in a weird way. Only the columns need to be offset because they start at 1. So we start with row 0. Now, what is row 0? I think we want to consider them stacks for real. So that means that when we put something on, so the idea would be that we consider 0 the top of the stack. And so when we put something on top, we push on the stack. That seems a good idea. The alternative would be to consider 0 the bottom of the stack. Maybe that's better. Yeah, maybe that is better. To consider 0 the bottom of the stack. I guess there are pros and cons for doing it either way, right? So, okay, I'll go with 0 being the bottom. So, okay, starting from row 0, here's what we want to do. We want a while loop. And while row is lower or equal than... what? Well, I guess we could say the biggest stack. What is it? What was it? 10 lines is the biggest? Well, no, not even. So we start at 1. Here is line 9. So they all do no more than 8. So it's basically 8. 8, which means 7 starting from 0. Okay, there's a good chance that I'm gonna mess up. I'm gonna do a off by 1 error, but whatever. As long as it's lower or equal than 7, right? Because it's 8 starting from 1, 7 starting from 0. We do want to increment row. Now, here the offsets are going to be complicated. Do I really want to consider 0 the bottom of the stack? I'm actually not sure. Whatever, it's fine. Okay, so for each row, we want to do stacks column C dot append. I want to append a new item. What's our item going to be? Also, this is try most certainly. Our item is going to be we need to split on the lines, don't we? We need the first n lines. So before we think about the stacks, let's do some pre-parsing of our stuff. So var line iterator tokenize u8 data new line, and we need the first 9 lines. Which kind of makes you want to do that by row. So now that I'm realizing this, probably doing it by row in some ways would be more efficient, but whatever. So let's do the first 9 lines by hand, I guess. So var lines. Well, how do we call these? I don't know. Data 1. It's like the first part of the data, right? It's an array of actually 8 items, 8 rows. And each is gonna be a slice. Each is gonna be a line. Actually, I could have used a for loop in here as well. Why did I not do that? I think I might want to change the outer while there to a for loop. So for each slot, we want the line to be line IT dot next, a question mark, because we want to answer that we are going to parse that. Okay, so now data 1 has the first part of the data, so we have the lines. So now we can do, yeah, this. Man, this column stuff doesn't really need to be like this. Although I do need to know this. It's fine, whatever. Okay, the item now goes to a line inside data 1. But which one? For row 0, we want to go to the last one. So that's like data, it's like 8 minus, oh no, 7 minus row. That puts us in the right row, yes. So when row is 0, we do the last one, yes. Now we need to pick the right column. Whew, now the math becomes annoying. So what is the right column? So the columns are gonna be 0, 1, 5, 9. So it's like 1 plus 4. Is that it? Well, 1 plus, 4 n times 4. So that means 1. Yeah, that means 5. That means 9. Yeah, okay. And so this is gonna be 1 plus column times 4. And then if item is a space, we want to break from this loop, right? Because it means that we went up, we don't have any more crates. Like we got all the crates for this column, and we don't need to do anything else anymore, so we can move to the next column. If it's a space, we break, otherwise we do that. Okay, hopefully this works. You know what? Let's add a print maybe, and let's inspect that we did everything correctly after the initialization. So for stacks, for each stack, std debug the print, also stack and index. We want to do, I guess, something like this. That's a single crate. For each crate, I guess we want to print the crate. Oh, but you know what? Since they are basically strings, here's what we can do. We can do it like this. Print them as a string. That should work. Let's see. No-field number main function init in ArrayList align u8 null. There is no init. ArrayLists don't have init. What am I missing? Of course they do. Let's go take a look in the documentation. Append the init we must certainly have an init. What is this thing smoking? Sorry, let me double check this. Stacks index C. They are calling it on C and not stacks.init. Stacks by itself is an array of these guys. So stack is an array of array lists. And stacks index C should be one of them. That's an interesting bug. Let's see. That is weird. Ooh, also I'm realizing something. the math here is wrong because C starts at 1. So this should be C minus 1 times 4. Okay. Oh, init is not the type, not a method that takes it itself. Oh, you are right. That is most definitely the thing that I was missing. You are right. This returns self. This is not a self method. Thank you very much. Yes, thank you. That is the problem. Caught me by surprise. That is 100% the problem. So we want basically to say this is there we go. Hey, Hazy Code, hello. Okay, let's see what else we got wrong. Invalid format string S for type array list unsigned. Oh yeah, right. This is on our items. There we go. I tend to use null value. Attempt to use null value. We want to tokenize data on a... Wait, sorry. Oh, you know why? I never saved data.txt. I pasted stuff in there, but apparently I didn't save it. Okay, let's see how far we get this time. Panic, reach unreachable code. Where? So we reach unreachable code while trying to print s.items. Why? So we're trying to print s.items and we reached something unreachable fault. Write failed. That is interesting. Oh, you know what we should not do probably? Probably copying this guy is a bad idea. But in this case, I don't think that any of the things that we're seeing now can be improved. Like this is the reason why this method has this signature is probably something to do with copying. The fact that our print is causing an error, that's still a mystery to me. So here's what I'm doing that it's not a good idea. This is creating a copy of each stack. But we're not using the copy to modify the data. So this shouldn't be a problem. This should be modifying the entry inside the array without issue. What is going on? Why is this problematic? We are not creating any temporary in here that we should be afraid of. Huh. This is interesting. And we are consistently panicking because we reach unreachable code. Could it be that we put something in here that cannot be printed? Not really. I mean, worst case, we have a bunch of... We don't find the characters in there that we would like to find. Oh! Here's the problem. Yeah, you're right. No, stacks is undefined shouldn't be initialized. That's what this piece of code does. But here's the problem. Here's the problem. Stacks 0 is garbage. The problem is that we explicitly decided to make stack index 0 uninitialized so that we could keep using C. That's the problem. That is the problem. So can't print it. I don't know. I'm starting to think that probably my choice to keep index 0 messed up so that we have to do fewer adjustments of the index. I don't know. For now, it doesn't seem to be paying off, but who knows? We'll see. Okay, so it seems that we parsed these bad boys correctly. So, okay, now let's take a look at the next step. Okay, so now we have to parse this, right? Now, there is one pure garbage, giga cheating way of parsing this trivially with tokenize. It's pure cheating. But I'll do it anyway. I'll show you the cheat. So, sorry, now you see this, you're tempted to think of regular expressions, right? But here's what you can do. Here's what a programming rogue would do. So now the idea is we parse the first 8 lines. Now there's the empty line, but the empty line is gonna be ignored by tokenize, so we can run away, keep pulling from the line iterator and obtain the subsequent lines. And here's what we do there. In all honesty, we don't even need... Man, this is so evil. We don't even need the line iterator anymore at this point. So here's how it's gonna work. Actually, out of curiosity, what's inside the line iterator? Because here's what I would like to do. I would like to inspect the line iterator at this point and see if we can get a slice that gives us the rest. So let's take a look at tokenize. Tokenize. This produces a token iterator, which is token iterator. Do we have like a rest? Oh, look at this. Returns a slice with the remaining bytes. Does not affect iterator's type. Okay, so here's the rest, right, of the data. So I'm gonna call it data 2. So var data 2. Well, actually, doesn't even need const rest. Let's call it rest. Line it.rest. And then here's what we do. I'm gonna call this one IT because I can, because the other, do I have a IT operator? No, I don't have any other IT in here. Okay, so I'm gonna call it IT. Here's what I'm gonna do. std mem tokenize. Here's what we tokenize on. U8 rest of the data. Move from to new line. There we go. And space. And now we can simply keep looping over it. And this is going to yield numbers. So I'm gonna call it num. And here's what we know. Const, let's do it like this. Const quantity, Q stands for quantity, is num. This is just like a reassignment for better comprehension. Quantity, and then it's from, right? And then const to. There we go. And then we want to parse them. So try. There we go, and we have quantity from and to. Here with the cheat code. Who needs regular expressions really? But you can see, right? We cover everything. We cover all the letters that we can want to split on, and now we just get 3 numbers at a time. No. Yep. Okay. So how do we use these things? For every loop, I'm gonna make q a var so that we can change it, and we'll say while q is greater than 0. And we keep decrementing it, q minus equals 1. And is it a problem that it's... Oh, here's the problem though. This is gonna work because I'm only looping as long as q is greater than 0. When q is 0, we're stopping. If you wanted to do this, then you cannot use a unsigned number, because unsigns are always greater or equal than 0. So you basically are triggering an underflow with the last check, which is not going to work. So that's something to keep in mind, but it shouldn't be the case for us now. Okay, so that's the quantity, and every time we select the from crate, so well, the from stack, sorry, stacks from pop, and we obtain an item, and then we try stacks to push, well, append. Hello, so delicious. Hello, hello. There we go. And if quantity is greater than 1, we do this more than once. Up, up, up. And then I guess we print. We could do this manually. Well, let's do it in a nice way. For stacks, ignoring the 0th one because we left that one undefined, which is not nice. I guess we could forcefully initialize that one to an empty thing so that we don't have to worry about it. You know what? I'll do it. So that also has the nice side effect of making these indices correct. So instead of ignoring the bad data, let's initialize it to something. So stacks 0 is std. Oops. There we go. Okay, this is not fixing because I have broken syntax here. So for each stack, actually, do I care about the index? Whatever. Yeah, I don't care about the index. What do I want to print? I want to print the stack.items -1, length -1. Although, oh, you know what? Yeah, you're right. I should print stack.pop. That's not a bad idea. That's not a bad idea. Although it should be maybe pop or null, because pop is going to explode. Index 0 we know contains nothing, so that's going to be a problem. Pop or null. Or else, and let's do a special character that tells us that there's something sus. Percentage character, it's my placeholder. Wow, what happened? Why did it become yellow? Expected semicolon, yeah. Okay, let's see what else we're doing. Can't do it because it's const, right? So we need to modify it, so we need to ask for a pointer. What else is there? Integer overflow, what? Yeah, so in pop What do you mean? It should be pop or null. Am I popping? Oh, here I'm popping. This is bad. This is bad. Why are we popping wrong? Did I misremember what the rule says? Move 1 from 1 to 4, right? Move something, move a number. I think my trick, my parsing trick needs some adjustments. So let's add some printing to this. Oh man, okay, yeah. What did we do wrong? Pop, quantity 1 from 2 to 3. Let's see if these are correct. Oh, we're missing 6 to 1. Wait a second. One, two, three. Something is missing. Something is wrong. We are tokenizing the rest. We have num in here. Then we grab next. Let's print also num, because num should be... Num should tell us where we are centered with the parsing. Num is a string. Num is 1 and then 4. You know what's happening? I forgot about this line here. So when earlier I said that we parse all this stuff so I don't have to worry, I forgot that there's also this line here. And we are basically parsing this line here. That's why we're getting these weird numbers. So I guess that before we grab the rest, we need to get one, throw away one last line. There we go. Yep, now everything works as intended. And then we have these. Oh, that's bad. That's bad because we need to print these bad boys as characters. The percentage, we know it's our placeholder, and then we have SVF DLG. Okay, so let's SVF DLG. DLG LWV. Oops. LWV. LWV. I'm sure I didn't make any mistake. Okay, I actually did not make any mistake. I was worried about the copy pasting more than anything else. I wish Zig would have good parser combinators. Zig actually has a good parser combinator. Let me introduce you to Zig Mecha. Hello, Karitam. Mecha, parser combinator library for Zig. You can actually do pretty neat stuff with this. I still honestly wouldn't recommend this for Advent of Code, simply from the perspective that it's really overkill. But yeah, it's there. You can do pretty fancy stuff with comp time. Like, yeah. I actually think that the name and the concept behind Mecha is on point. Yep. Okay, dependencies are a pain in Zig for now. Yeah, a little bit. We're getting there. So we need to do part 2, right? Yes. Let's do part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. The mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't crate mover 9000, it's a crate mover 9001. Grid Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. What do you know? Again, considering the example above, the crates begin in the same configuration, blah blah blah, moving a single crate from stack 2, blah blah blah, behaves as before. However, the action of moving 3 crates from stack 1 to stack 3 changes the order. That's the only difference, right? Okay, so we need to implement this other version. My D5 solution is like 200 lines, parsing was actual pain. I guess you didn't know about tokenized move FRT. Let me introduce you to my friend. I'm doing the parsing, like, I don't know, I spent maybe 10, 15 lines for parsing. Oh, okay, maybe 20, but it's like, that wasn't a big of a problem, but I am cutting corners for the purpose of Advent of Code. Okay, so we are not moving one stack at a time. We are moving them all at once, so this is not a while loop. This is different. We have to... So what operations do we have in here? Stack from ZLS? Come on. Unexpected pointer dereference. Oh, it's stacks. Append n times append. So we have append slice. That's nice. We don't have pop slice. That's annoying. It is annoying. So we don't have an operation to pop and... Okay, let's take a look at the documentation just briefly, just to see what operations we have. I mean, we can survive this. It's not a big deal, but hey Matt, hello. Let's see, what do we have? Add many, add one, add allocated slice, append. Okay, these are all about adding and appending stuff. Append, clear and free, clone, ensure total capacity. I'm sorry, I don't have these sods. Expand in capacity. We need something like shrink. Ooh, this is nice. Replace range. Replace the range of elements with new items. Not exactly. Close, but not quite. Resize. Adjust the link strength. The list length to new len. Shrink and free. Shrink retaining capacity. Swap remove to own slice soon and use capacity writer. Yeah, we don't have anything to mass remove items from the array list. That could be not a bad operation to have, but we don't have it now. And so, yep, we concatenate pops. So here's how it works. We pop in a temporary slice, and then we move from there to the destination. That's going to be our plan. Yeah, that's a nice doc page. Isn't that right, Matt? So let's go do that. So we don't need this print anymore because we know we can trust our stuff. So here's how we do. Instead of appending to the item, we need a temporary thing. So let's make it var temp it's an array list of bytes. That pop-up was a little bit worked, but oh well. So we keep popping and we keep pushing to temp. Put, add, append. So we keep appending there, and then now we want to kind of iterate them backwards. So we kind of want to pop them again, right? From temp. So I guess we can do this while temp.pop or null item. We put it in the stack. That works. What about append slice plus resize? Appending slice works. Oh, sorry, you mean append slice? So yes, we can do append slice. The problem is that this is out of order, right? We put stuff backwards in our temp array compared to what we would want. So either I change this append to some kind of prepend, which is annoying. And I think it's very inefficient for arrays to do that. So either I change this append to a prepend, or I do the pop again to preserve the original ordering. Why temp as an array list? You know the size to be q. I know the size to be q, but q is still a runtime parameter. Never mind for a moment that I am embedding this data into the executable at comp time, so technically this stuff is known at comp time given the trick that I'm using. But in a more general sense, when Q is provided by the data in a normal program, that is runtime known, and you cannot create static arrays from runtime known lengths. You can only create array lists. What you could do is tell the array list how big it should be. So you can do this. You can say there's this one init capacity. Oh my god. Okay, is where I'll get there in a moment. So you can do init capacity that takes a number, so you could pass q, and that's like an optimization because it creates the array list with the right size right away. But that's pretty much all you can do. Oh, hello Jacob. So I don't know, let's see how it goes. Oh, error is ignored. Yes, we need to try. Well, I don't know. Simply reasonable. DCVT. CVPCL. So the reason why I'm doing this manually is because I can't copy paste from my goddamn terminal. That's why. I don't know why it's broken. That's the right answer. We got a gold star. A5 completed. Okay, should we attempt day 6 or not? I think we can do day 6 as well. What do you think? Yeah, I mean, couple hours total. Should be fine. Less famous words, but... Okay, before I read, let's do... let's make a new folder. What about to own slice? To own slice is about memory management more than anything else. It's basically ejecting the underlying array that the array list has been managing up until now, giving it to you, but now you're the owner of that memory, so it's on you the onus of freeing that memory at the right moment. So these things are like more about proper software engineering than the weird data science stuff that we were doing in Advent of Code. I could have used, by the way, I mean, remove order range. Wait, what did I miss? Oh, I think I missed your comment, AZ Code, because I was replying to this one. Let's see. I looked for the same for bounded array. I think the stdlib could have remove order slice on these containers. Yeah, I agree. I think that these containers could maybe use a couple more methods. But you know what? Here's the thing. The reason why these methods are not there is because nobody has needed them really when developing the compiler and I guess the bigger Zig projects. I think there's really nothing wrong in adding these couple extra methods, even if they might not be, you know, as generally useful as they seem to be while doing Advent of Code. But yeah, by the way, I would recommend if anybody here is thinks that we should have those, consider contributing them. Take a look at this. Pyrolystical made this blog post where basically, I'll just read from the text. While doing Advent of Code, when I tried to use static bitset, I was surprised it was missing a function to determine if one static bitset is the subset of another. My solution required to check a pair of sets where either a subset of one or the other, if a pair of sets were either a subset of one or the other, blah blah blah, and then it says, yeah, wanted to add these, made a pull request, and it was merged already. If you grab latest Zig, now you have these bad boys. So keep in mind that Zig shouldn't be super optimize, right? We shouldn't super optimize for being a language good for something advent of code. But yeah, stuff like this, where if you can generalize it as something generally useful, and I know this is not like a clear-cut thing, there's always opinion, but if it's not a lot of work, and I don't think that any of this is a lot of work, and you want to try your hand at making a PR, make a PR. Worst case, somebody will tell you their opinion, like one of the maintainers will tell you if they think there should be a change or if it's maybe not a good fit, but you will not have wasted a lot of time, and chances are that it's gonna get merged. Just like this one got merged, and everybody's happy. Oh, hey Ben! Okay. Now, man, differentiate yourself. We push you on leaderboards by shipping with advent of code answers in the standard library. That would be cool. By the way, Ben has been doing insane stuff. So we were just doing the crate one, right? Look what he posted on Twitter. Review your email. Yes, that's still my email. Jesus. Look at what Ben is doing. So I'm doing the advent of code scrub mode, where I'm coding it in a programming language. He's doing it in Dreams. There's an actual elf on a pier with a boat, an actual crane moving actual crates. So, like, okay, you remember how I'm saying, no, I'm gonna cut every corner, I'm gonna do the minimum amount of work necessary to get to the answer. I don't give a fuck about parsing, doing like robust parsing, because our data is always gonna be correct. We only have to parse one data input, that's it, then we're done. This is the opposite end of the spectrum. There's the actual elf on the pier looking at the crates being moved. Oh man. So that's awesome. That's really awesome. And he's streaming those, so I don't know if he streamed this one, but you should check out his yeah, look at this. Look at his Twitch. He's doing this on stream, so I don't know. At the end of the day, not only you know how to solve the advent of code, you also know how to do game dev, I guess, with Dreams at least. That's crazy. Yeah. The only catch is that I can't actually compute the real answers that way. Yeah, right. In 2 hours. I think it's super cool, Ben. It's really nice. That's one of the most interesting and creative uses of, I guess, ways of approaching advent of code that I've seen. Pretty cool. Okay, let's go. Okay. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way toward the Star Fruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. Oh my god, the damn elves? Oh, spoilers, sorry Ben. I'm a number of people doing set intersection stuff for day 4. It seemed way overkill to me since you have continuous ranges of numbers. Yeah, I didn't do this. I just did the ranges. Sorry, ranges. I just looked at the extremes, and it's like you don't even need all the extremes, because since I think that people that have designed the exercise did this on purpose. They made both extremes overlap, so they weren't open ranges, they were closed ranges, and by doing that, you just needed to pick one of the two extremes, check that that point is inside the other range, and you're good to go. It's like one line where you have to change a little bit. Yeah. In any case, I'm not judging, because the reality is that I'm not aiming for the most performant solution. I'm aiming for the most lazy solution, and I guess in that case, checking the extremes happen to be both performant and the lazy solution. Fewer keystrokes. Okay, so we have to set up a communication system, which means that the damn elves are asking us to make another account on another social media platform. So it's like they have Mastodon or something. For that one, I just threw if statements I did until I got the right answer. It was, so, I don't know, I don't always get the smartest answer, but let me show you what I did, since I guess you guys weren't here. Day 4, right? Yeah, this is part 2. It's like just a couple of things. Well, it ended up being pretty straightforward. I occasionally don't get this right first try. In this case, it happened that I also did get those right first try. Also, you will notice that I'm using another parsing hack here with tokenizer, because I'm not like splitting with a comma and then splitting with a dash. I'm splitting with both at once, and then I know that I'm gonna get the numbers in the right order. Okay, so let's see. However, because it's heard you have significant experience dealing with signal-based systems, oh, I guess these are all the old, I don't know, the codes where you had to do the same thing. He convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock on their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of a packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4-character marker, so including the 4-character marker. For example, suppose you receive the following data stream buffer. This is interesting. There's partially related to this. I'm sure this will not have to come up in this exercise, but there's a, let me see if I can find it. I have a book on string algorithms that I don't remember where I put. But there's a very funny algorithm that specifically helps you optimize this stuff. It's like it's the Z-box algorithm. Oh, Z-blocks, yeah. Yeah, in any case, it's a neat algorithm that allows you to speed up this kind of stuff. Probably we won't need it today, but anyway, tiny thing. Skellinger, thank you for the Prime sub. Thank you very much. Thank you for the base of bucks. Okay, let's see. After the first 3 characters, M, J, Q have been received, there haven't been enough characters received yet to find a marker. The first time a marker could occur is after the 4th character is received, making the most recent 4 characters M, J, QJ, but J is repeated, so that's not good, and you have to shift over. Okay, let's get our puzzle input. I've been using Stream Reader. I didn't know about SDMM tokenize. Maybe I'll try out tomorrow. Yeah, Hazy, I actually recommend it. It's pretty neat. Okay, we have our data. Have our STD. I've been using mostly split. Split is kind of as good. Split is necessary when you care about like empty slices. If you care about them, and I think I did for the first day, when you had to also count like the empty line between one alpha and the other, split was better than tokenize. Otherwise, when you don't care about empty lines, tokenize is good enough. Or I guess better, because it just doesn't produce empty slices ever. Okay. So we need to parse our stuff, right? I guess we can... Man, I'm starting to worry that actually the ZBox stuff might come in handy for real. But I guess we can start with the naive version and it should be good enough. Also, how big is our input? 4,000 characters. That's easy. You could do the most inefficient thing and it's gonna be good enough. Okay. So this time we don't have to iterate over, we don't have to tokenize anything, we don't have to parse anything. What we want to do is, I guess, start with our slice, then move the slice. So, you know what we can do? Here's what we can do. Let's take a look at the input data. Going to the beginning, we know the first 4 characters are not a match. So we can basically initialize our slice with the first 4 characters and know that they are not going to be a match already. So I don't know, what am I gonna call it? Var window, I guess. It's gonna be data from 0 to 4. Now here's the problem. In Zig, when you create a slice, or rather, when you slice a sequence, when you slice another slice, or when you slice an array, and both extremes are compile time known, you are not creating a slice, but you're creating a pointer to an array of length 4. Is that a problem? It should not be a problem in our case. So I'm not gonna do anything, I'm gonna leave it there. But just so you know, the point is, this is not like, that's not the type that we get back from this. The type that we get back coerces to this, but what we get back in reality is this. That's what we get back, and without the const. Const goes here. But this type coerces to a constant slice. So anyway, small detail. Now, what do we do next? We have our window, we need to check our window, and then we have to move it forward. What's our condition exactly? We want the latest? How many characters need to be processed before the first start of packet marker is detected? Okay, so we have to count how many characters until then. That's annoying. So it's kind of tempting me to do a while loop, I guess. Yeah, let's do a while loop. I guess window is gonna be something different. So var end, I guess I'm gonna call it end. Starts at 4. Come on, 4. While end is lower than data.len, and plus equals 1. We increment it by 1. Missing a colony here. And in here we do this kind of stuff here. So I guess we can, yeah, we can do const. I'm gonna call it just W for window. A modified return const by, so it's the same type as a string literal. Yes. So this is already a pointer to an array, yes. But occasionally people get confused because they slice on something and think that slicing always produces a slice, but it doesn't. Occasionally a slice, the slicing operation produces a pointer to an array. And it's not a big deal unless you are not fully aware of coercion rules, and you're maybe trying to make like, I don't know, like an array of slices, and it turns out that some type got like slightly overly specialized, so Zig doesn't assume that something should be all slices when technically could be. That I remember occasionally stumbling upon this, but minor thing. Okay, so a window then is gonna be data end -4 ... end, pretty much, and then we check W and we say if it matches our property. How do we check that all 4 characters are different? That's annoying. I guess I can check the first character with... Man, that is annoying. It is indeed annoying. Ah. Set is very overkill for 4. You're reading my mind. That's exactly what I was thinking. It's very overkill. But you know what? It saves me some typing, and it works. And my philosophy is the laziest solution, so... There are only 256 characters though. Yep, knowing that your base is not particularly big helps a lot. It's one of those secret tricks. You know when this type of knowledge becomes a real killer? When you're doing bioinformatics, because you only have 4 bases. Well, not exactly 4, but like it's close enough. And knowing that you only have 4 bases allows you to do very funny transformations, because you know that like things that otherwise would be combinatorially problematic, knowing that you only have 4 potential values helps doing, you know, funny transforms. That's fun. I mean, you could accumulate in a bit set, I guess. I'm not familiar with those data structures. You know what? I'll just do a boring normal set, like a boring normal hash map, and call it a day, I guess. Although, okay, I'm curious. Oh, you know what I can do? Here's what I can do. Here's what I'm gonna do. I have the slice, right? Let's take a look at what's in mem. I think we have like some search things in mem. You know what? Just show me what's in mem. Count. We could do count. We could do count, or we could do contains. Where's contains? Contains at least. I mean, it's kind of like as count. Contains at least, I guess, could be slightly more performant, but counts is good enough. So here's what I'm gonna do. 4. For each thing in the window, I want to know the character and the index. And here's what I'm gonna do. Index of different than null. Yeah, that's good also. Yeah, you're right. That's what I should do probably. I mean, there's no difference, right, between count and index of scalar. In reality. But I like index of. let me take a look at those signatures. Index of any, index of diff, index of min max. Linear search for the index of a scalar value inside a slice. Yeah. Well, we want count greater than 1 or greater than 0. Yeah, but you can always exclude, you can always start later, right, in the slice. Like you kind of do forward searches, which also saves you some loops. Let me show you what I mean. So we know the character, we know its index. So here's what we do. We do index of, so we do if w slice, hi Hazy Code, yes, thank you for stopping by. So we start from idx until the end, and we say, sorry, we start from idx plus 1, and we do what is it, std.mem.next of scalar linear search for the index of a scalar value inside the slice. Type u8 slice, this is the slice. Value that we're looking for is the character. So we're searching forwards. I think this is not n squared. I think this is slightly less than n squared. It's not linear. Yes, it's better than nothing. One thing that I probably could help is like maybe building some tables, but who cares? This should be good enough. So wait, if index of scalar, what does this return, man? Yes. Go to definition. Returns an optional usize, right? So we want to check for null. If it's different than null, then we want to move forward with the while loop. So we need to give a label to the while loop. No, I don't know. I don't need any snippet. I don't need any snippet. God damn it. A triangle is alpha square semi-asymptotics. Okay. So index of scalar this. If it's different than null, then we break to outer. Well, sorry, no, not exactly break outer. We want to continue outer. While if it is null, while if we got null for all of them, so we ended the entire for loop and we never succeeded, then that's our end condition. So we, I guess, want to print end at this point. Here's what we can do. Here's what I'm gonna do. I'm gonna print data, and then I'm gonna print a string, and then I'm going to print, well, here's what I'm gonna do. I'm gonna print the len, and then I'm gonna print the data. So here's how it works. We print end, and then we print data from 0 to end. It's only for consecutive duplicates. You would have to sort first. Collapse repeats? Wait, Jacobi, are you replying to me or are you replying to Skellinger? Okay. Okay, is this okay? These four characters are different. Inspecting visually, see a bunch of repetitions, so that seems reasonable. I'm a moron. Why is this thing printed? Why did I put the print in here? Also, wait. If we got here... If we got here, then we also want to break, right? Don't want to loop anymore at that point. Okay. That's better. Us RTM. Yes, they're different. Bunch of repetitions. Yes. So 1802. Let's see. That's the right answer. Part 2. Your device communication system is correctly detecting packets, but still isn't working. Looks like it also needs to look for messages. Start of message marker is just like a start of packet marker, except it consists of, god damn it, 14 distinct characters rather than 4. So I guess we are getting punished hard. Here are the first positions of start of message markers for all the messages above. So we need to do the same. How many characters need to be processed before the first start of message marker is detected? Wait a second. Do we need to... Is what we did just now unrelated now? Or do we need to combine them? So let me reread to make sure. It also needs to look for messages. Start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. So I guess we just need to change that to 14 and that's it. I don't think that what we did just now, so like these are not different things. Like, yeah, I think it's the same. Okay, let's change these to 14 and let's watch it burn, I guess. So we start at position 14. We do minus 14. We do the same thing. And I don't know, would be nice if this thing simd'd the fuck out of that loop. Okay, it seems that we don't have much trouble making it happen. 3551. That's the right answer. Okay, that was easy. What is this? Punishment if you're using like a slow language? Would be nice to see when it starts becoming problematic. It was pretty instant though. This was a debug build. Everything was debugged, so... Yep. Well, there we go. That was it. That wasn't particularly hard, I say, for now. Day 6. Well, I think the first ones shouldn't be particularly hard, right? I think that when I stopped around day 16 in the past was because there was like a bunch of matrix operations, and at some point, like some tiles made of tiles needed to be rearranged, and you needed to do combinatorics or like try all combinations with backtracking. And at some point, one of the operations they were supposed to like to flip. I think you were allowed to rotate, but not flip. And I probably got the math wrong there, and it wouldn't work, so I was annoyed. But in any case, for now it's working. So, yeah. That's it. I guess I'll see you all tomorrow. Maybe. With a single exercise. But you know what? For now, I think we can probably try to batch them a little bit and do more than one at a time. So I hope everybody had fun. I'm gonna upload this video on YouTube. I already published on YouTube the previous day. You can go, it's on the stream title, but if you go to youtube.com, see showtime. There we go. Days 1, 2, and 3 of Advent of Code 2022. And there's gonna be also days, I guess 4, 5, and 6 now. Last note, I'm gonna say it now, but I'm gonna repeat it also probably tomorrow, whenever. I'm away this weekend, so I will be collecting some more exercises. I can become a backlog of exercises soon again, so I'm sorry you will have to survive on your own like you had to in the first few days. But really, at the end of the day, I'm just showing you tricks. Now you know how to abuse tokenize, you know how to use the Zstandard library hash map as a set. You know how to survive without set intersection. That's probably not that hard. and I don't think there's much else that was really that important that we saw these few days. So hope you have fun, and I'll see you next time. Bye bye.